Hello and welcome. In this video, we're going to be looking at yet another super tough mechanics question. I think this is one of the toughest questions that ever came in Cambridge exams. We're going to look on how to solve it. These types of questions are super useful because they combine lots of ideas, even if they're not going to come with the same hardness in other tests. Combining ideas and seeing how ideas relate to each other or chapters relate to each other will help you in even medium questions, which are most of the test is about. Anyways, this is the February March 42 paper for 2023. Let's start by reading the question and trying to figure out how to solve this question. So the diagram shows a smooth track. Smooth means that there is no friction along the whole track, which lies in a vertical plane. The section AB is quarter a circle, okay, of radius 1.8 with center O. The section BC is horizontal straight line of length 7 meters, and OB is perpendicular to BC. Okay. The section CFE looks like a slope, it looks like an incline, and it has an angle theta. We're not given the angle, and this angle is between the slope and the horizontal. A particle P of mass 0.5 kilograms, so let's say this is particle P, is released from rest at A. Particle P collides with another particle Q of mass 0.1 kilogram, which is at rest at B. So there is another particle Q over here. Immediately after the collision, the speed of P is 4 meters in the direction BC. So these two are going to collide. This looks like a momentum question. And after the collision, this particle is going to move in the direction BC with a speed of 4 meters per second. You should assume that P is moving horizontally when it collides to Q. Show that the speed of Q immediately after the collision is 10 meters per second. Okay, so since this looks like momentum, let's start by this momentum idea. Let's see, what do we know about momentum? We know the conservation of momentum equation, which is m1 times u1, mass of particle 1 times the initial velocity of particle 1, plus mass of particle 2 times initial velocity of particle 2 equals mass of particle 1 times final velocity of particle 1 plus mass of particle 2 times final velocity of particle 2. That's the conservation of momentum. So let's draw our particles. This part here says that you should assume that P is moving horizontally when it collides with Q. So let's say this is P, which has a mass of 0.5 kilograms, okay? It's moving with an initial velocity horizontally. Do we know it? No, we don't. Let's call it U1, okay? And this is particle Q of mass 0.1 kilograms, okay? And it has a U, or an initial velocity, of 0 meters per second because it was mentioned that it was at rest. Yeah, particle Q, which is at rest at B. Now, immediately after the collision, what happened? We have the final velocity of P after the collision. It says it moves to the right with a value of 4 meters per second. And then obviously Q, if something hit it from the left and P is moving to the right, obviously Q is gonna also move to the right. This is P, this is Q with some velocity V2, okay? Now, the problem here is that we have two unknowns, U1 and V2. So if we have U1, somehow we can use this conservation of momentum equation to find V2. So let's think about a way how can we get U1. Now, P, we have given some information about P, that it started at rest and it moved along this quarter of a circle, okay? So this looks like P had some kinetic energy or gravitational potential energy that changed to kinetic energy. So basically we're looking at work and energy transfer and. In this type of questions, I gave you a magic formula that will work for every single work energy related question. It looks like this. It says that work in minus work out is equal to change in kinetic energy of the particle plus change in gravitational potential energy of my system. Work in is any work is any work due to a force. We know that work is due to a force. Work is force times distance. Work in is due to any force that's giving energy into my system. Example, like a driving force, like a pushing force, a pulling force, something that's giving energy to my system. If I'm pushing P down, if I'm pulling it this way using a force, this is going to contribute in the work in. Do we have any force, external force? And by the way, work in, we do not include the weight because the weight is included in changing gravitational potential energy. So any external force other than the weight. Do we have anything here in that sense? No, we don't. So our work in is 0. Minus work out is the exact opposite, is any external force, or it's the work due to any external force that takes energy out of my system. Like what? Like resistance, like friction, like drag, or a force that is opposing motion. Do I have anything, any external force on P in that sense over here? No. So again, my force is 0. So my work out is also 0. Is going to equal changing kinetic energy. So changing kinetic energy is kinetic energy final minus kinetic energy initial. So we can say it's half times mass. What is the mass of P? It's 0.5 times the velocity final of P, which is what I want. I want the velocity exactly before the collision, which is going to be the initial velocity in the momentum part. Can you see how we can relate the chapters together? So have v squared, I'm just going to call it v squared, minus the initial velocity squared. What was the initial velocity of P? It was 0. So minus 0 squared. And then plus changing gravitational potential energy, it's mg delta h. So m is 0.5, g is always 10 for Cambridge, and delta h. What's delta H? What's the vertical displacement that P moved? I know that P was here and then it was at this level. So I moved an H of 1.8. It moved below its starting point. So my H is going to be negative, and that's it. This is my equation over here. Now I can put this left side as 0 equals half times 0.5 is 0.25 times V squared. And then I have 0.5 times negative 1.8 times g is going to be negative 1.4 g. So from here, I can say that 1.4 g equals 0.25 v squared. Divide 0.25 both sides. And then we're going to reach to this. Then we can square root both sides to find v. This is going to give me 1.4 times 10 over 0.25, everything under the square root. There is something probably wrong here. 0.5 times 1.8. 0.5 times 1.8 is not 1.4, it's 0.9. So this is 0.9, my bad. So instead of 1.4, we just replace it with 0.9. So if we do this on the calculator, square root of 0.9 times 10 over 0.25, it's going to give us the V value of 6 meters per second. So now, this is the final velocity that P reached, okay? Which is going to be the initial velocity just before the collision, which is going to be 6 meters per second as we calculated over here. So now, since we have U1, we can use this conservation of momentum equation to find our answer. So I'm going to do it here. So what is M1? M1 is 0.5 times U1, which is 6. And by the way, you need to choose a positive direction here. Okay, here every single velocity is pointing to the right. So in this particular example, it's not going to matter. But I need to know that my right side, I'm going to take as positive. Any velocity pointing to the right, I'm going to put it as positive in my equation. Any velocity pointing to the left, I'm going to put it as negative. So M1 times U1 plus M2 times U2. What is U2? The initial velocity is 0. This is going to equal M1 times V1, so 0.5 times V1, which is the final velocity of P, which was 4, positive 4, plus M2 times V2, which is my unknown that I want to know. So this part over here is going to be 0.5 times 6 is 3, equals 0.5 times 4 is 2, plus 0.1 V2. So put the 2 over there. 3 minus 2 is 1. 1 equals 0.1 v2. So v2 is going to equal 1 over 0.1, which is going to give me 10 meters per second. And this is what I was supposed to show in this equation, that q immediately after the collision, the speed of q, which is v2, is 10, and we calculated it as 10, so that is correct. Now, let's read part B. Part B says when Q, so now P and Q collided, Q is going to move in to the right, okay, with a velocity of 10 meters per second. Type. Can I ask you something? Is Q going to slow down, or is it going to keep on moving with this velocity? Ask yourself. If you said slow down, I'm going to tell you you are wrong. Why? Because slowing down means that there is change in speed. If there is change in speed, it means that I have change, it means that I have acceleration. Okay, and acceleration, we know that force equals mass times acceleration. In order to have acceleration, I need to have an external force acting on my particle. Q, after the collision, Q is moving to the right, yeah? In the right direction, do I have any external force acting on Q? Do I have any force? No, there is no force acting on it, and the track is smooth, so there is no friction as well. So force, the external force or sigma forces, is 0, which makes my acceleration 0 as well. So if I have no acceleration, it means that I'm going to move with constant velocity, which is 10 meters per second. That's what's going to happen to Q. Okay, now let's continue. So Q is going to move to the right with a speed of 10 meters per second, constant speed. When Q reaches C, it collides with yet another particle R. So there is another particle R over here, which is at rest. The two particles coalesce. Okay, what does this mean? It means that they combine and become one single particle. This keyword is super, super important for the momentum chapter. And by the way, I did a complete Mechanics 1 course that addresses every single keyword and every single thing you need to know about mechanics from start in order to master your exam. The course is 15 hours of content. It's on Udemy. It's super high quality. It's literally a gift I would have given myself when I was your age. I'm going to leave a link to it on the top right hand corner. Please feel free to check it out. If you're interested, email me and I might have some discount codes that I can share with you. Right, so we were talking about coalesce. So coalesce means that they're going to combine to one single particle, and this particle is going to have a mass of their combined masses together. The combined particles comes instantaneously to rest at F. So the particle is going to move up, and we know that nothing is going to keep on moving up indefinitely. It's going to slow down and stop. It stops at F and then comes back down. Okay, you should assume that there is no instantaneous change in speed as the combined particle leaves C. So the speed that was moving with at C is going to continue with up. Okay, so basically the speed after the collision is going to be the same speed it's moving up the plane, and nor when it passes through C again as it returns down. Again, when it's returning down, it's going to be returning with some speed, okay, and then it's going to move horizontally. So in real life situations, this is going to cause some change in speed because there is some impact. However, in our model here, we're going to assume that this speed is V and this speed is V as well, okay? Now, given that the distance CF is 0.4, find the value of theta. Okay, this is interesting. So let's see what we can do here. So again, let's do the momentum part. So we know that Q is going to be moving with an initial speed of 10 meters per second to the right, and it has a mass of 0.1 kilograms, okay? And we know that C is over here, so this is Q and R. R has a mass of 0.4 kilograms and it has a U value of 0. Okay. After the collision, they are both going to combine and move with the same speed. Let's call it V. So let's apply the same equation, m1u1 plus m2u2 equals m1v1 plus m2v2. m1 is 0.1, u1 is 10. Again, I'm going to take right as positive, plus m2 0.4 times u2, which is 0, so it's just going to be plus 0, equals m. Now, the mass of both particles because they combine. So I'm gonna have just single mass of 0.5 and a single velocity v. So the equation for a combined or coalesce or particles that combine together is gonna be m1u1 plus m2u2 equals m1 plus m2 times a single velocity v. So from here I can find this velocity v is going to equal 0.1 times 10 is 1. 1 divides 0.5 is going to be basically 2 meters per second. So the velocity after the collision is going to be 2 meters per second, and due to this part we're going to assume that this is also going to be the initial velocity it has when it's going up the plane. Okay, so now we know that v is 2 meters per second. Now to find theta, we have multiple options. We can do the work in minus work out equation. However, I want to solve it in another way, just to show you every single way you can solve this one. So let's draw the slope. The slope looks like this. Okay, we know that point F is over here. Okay, the particle is gonna reach this point F. We know that this is theta. We know that point F is 1.4 meters from C. And we know that the particle is going to be moving up the slope over here. Now, what's gonna happen here is I know that the particle is gonna have some acceleration downwards. Why? Because I'm gonna have a resultant force down the slope. How? Let me draw the forces for you. So I'm going to have the weight, which is gonna be 0.5 times g. I'm gonna have the normal reaction. Okay, I don't have friction because this is a smooth track. Let's resolve this weight into two components, the component parallel to the slope and the component perpendicular to the slope. If this is theta, this is theta. This is going to be 0.5 g sine theta. This is going to be 0.5 g cosine theta. Now, we know that we're going to have some acceleration downwards. Yeah, we're going to have some acceleration downwards. Let's use sigma f equals mass times acceleration for the direction parallel to the slope. Okay, I'm gonna take the direction of the acceleration as positive, so any force pointing down the slope is gonna be positive. So the 0.5 g sine theta, which is the only force in this direction, is going to be positive and is going to equal mass times acceleration, so it's equal to 0.5 times acceleration. I can see that I can cancel 0.5, 0.5. G sine theta equals acceleration. So the question requires me to find theta, and from this equation, if I have the acceleration, okay, I can easily find theta. So let's work on getting the acceleration. How can I get the acceleration? I can say that, okay, the particle started at the bottom and then moved the distance of 1.4. Let's use kinematics here. So let's take a positive direction up the slope and let's see what do we have from kinematics. We know that u, or the initial velocity of the particle, is going to be this velocity that we calculated earlier after the collision, and we said that this horizontal is going to equal this inclined speed because of this assumption that we had in the question. So our u is going to be up the slope 2 meters per second. Our distance or displacement is going to be 1.4 meters. Okay, I know that my speed at f is going to equal 0 because it comes at rest, and I want to know the acceleration over here. So I have initial velocity, displacement, final velocity, and I need acceleration. I didn't mention time, so I would like to use the equation that doesn't have time. And again, my course shows you exactly which equation to use in a very systematic and simple way. So the equation that doesn't have time is v squared equals u squared plus 2as. So v is 0 equals u squared, so 2 squared, plus 2 times acceleration times displacement, which is 1.4. So negative 4 equals 2 times 1.4 is 2.8, is it? Oh, this distance is not 1.4, it's 0.4. Where is it? Yeah, it's 0.4. So this is 0.4. So this over here is 0.4. Okay, so basically moving this 2 to the other side is going to give us a negative 4 equals 2 times 0.4 is 0.8 acceleration divides 0.8 divides 0.8. Acceleration is going to equal negative 4 divided 0.8 is going to equal negative 5 meters per second squared, and the negative indicates that it's opposite to our initial assumption, so acceleration is pointing this way, and this is what we assumed, and this is the correct thing. So now, using this equation, okay, we can substitute the acceleration, okay, which is going to be 5. We're not going to put negative 5. We know that the acceleration has a magnitude of 5 meters per second, and here we already said that the direction going down is going to be the positive direction. That's why I took the 0.5 g sine theta as positive, and that's why my acceleration is also going to be positive. So sine theta is going to equal 5 over g. So sine theta equals 5 over 10, which is 0.5. So theta is going to equal shift sine or sine inverse of 0.5, which is 30 degrees. So this is my answer for the theta for the second question. The first two questions are medium difficulty, but the hard part lies in this next question, and this idea comes a lot, so please try to follow through, and if you have any questions, leave them in the comments section down below. Now, the question asks, find the distance from B at which P, the original particle, remember P, this particle, at which P collides with the combined particle. Okay, that's super interesting. What happens here is that P is moving down, it hit particle Q, and then after the collision, P is going to continue moving with 4 meters per second, and Q is moving with 10 meters per second. So P is moving, but Q is moving faster. So Q is here, let's say, and P is here, for example. Yeah, Q is going to hit R, they're going to go up the slope, down the slope again, and then they're both going to move to the left on this horizontal part, and then collide with P, which is moving to the right. So this is the whole scenario, but if you think about it as a whole scenario, it's going to be super tough. So the best thing to do is to divide it into smaller parts. So what I want to know is how much time have passed, okay, since Q moved to the right, hit R, they both came up, and then they both came down to C. So now let's take the time period for this first part where Q hit R. So I know that at this instant Q is moving with a constant velocity of 10 meters per second. So constant velocity means zero acceleration. I'm just going to use V equals D over T. So 10 equals the distance which Q moved, which is 7 meters until it reached here. It moved 7 meters over the time it took. So the time is going to be 7 over 10, or basically 0.7 seconds. So that's the initial time that Q took in order to move from B to C. Now I want to find the time it took for Q and R after their collision to go up to F and then come back to C again. So let's see how we can do that. Now, I know that for particle QR, I know that acceleration is 5 meters per second squared down the slope, right? And I know that their initial velocity, remember the initial velocity after the collision, which was V, which we calculated as 2 meters per second. So their initial velocity is 2 meters per second. So here let's use kinematics. Let's actually use up the slope as positive. So the u is going to be positive because it's pointing up the slope. However, the acceleration is going to be negative. So this negative halas makes me erase the down slope part. So I have a, I have u, I have the displacement. The displacement I need is the final position. So I'm interested in the part where QR moved up to F and then moved down to C again. So my displacement actually that I'm interested in, and this is gonna make my life easier, is 0, right? I wanna know at what times, okay, how long it took for the displacement to become 0 again, okay? That is better than taking, okay, displacement as 0.4 for this initial part, find the time for it to go to F, and then find the time for it to move another 0.4. So this part makes it super easy and straightforward. Yeah. So I want to know how long did it take, okay, for this to happen, and I also want to know what's the final velocity when QR is moving down. Okay, so let's use kinematics. First, let's find the time. So to find time, it's obvious that I need to choose the equation that doesn't have a v because I don't have v, right? So the equation that doesn't have a v is s equals ut plus half at squared. So s is 0, u is 2, time I don't know, plus half times acceleration is negative 5 times t squared. So half times negative 5 is negative 2.5. Moving that to the other side is going to become 2.5 t squared. Moving the 2t to the other side is going to become minus 2t equals 0. And from here, this is going to give me two solutions. I can take a t out. So it's going to be 2.5 t minus 2 equals 0. So two solutions. First one when t equals 0. And this is obvious because our displacement at the beginning was 0. Right? And the second answer is going to be when 2.5t minus 2 equals 0. So 2.5t equals 2. Divide 2.5, t equals 2 divide 2.5 is 0.8 seconds. So now, what I know is, first, it took 0.7 seconds for Q to move until it reached C. And then it took 0.8 seconds for the combined particle to move to F and then back down again. So the total time it took is 0.7 plus 0.8. That's equal to 1.5 seconds. So that is the time that have passed since the first ever collision. So the time that have passed is also going to be the same time that has passed for P. So let's see after 1.5 seconds after the collision, where is P? Yeah. So I know from here that P is going to be moving with a constant velocity of 4 meters per second. So I know that 4 velocity equals distance over time. So 4 equals some distance that P moved over the total time, which is 1.5. So D equals 4 times 1.5. So D equals 6 meters. So I'm basically saying for the time period, let's erase this to make it a little bit neater. For the time period that all of this happened, okay, P was here, Q moved down, P moved down to hit Q. Now we start our timer. Q moves all the way to C, it took 0.5 seconds. Q collides with R, goes up to F and back down to C again. This process takes another 0.8 seconds. So now we are at this point and 1.5 seconds have passed. P, during this time, from here, P moved 6 meters. So now, P is over here, is 6 meters. So now this is P, this is 6 meters. And here, this is particle QR. The P is moving to the right with velocity of 4 meters per second. Let's draw this a little bit better. Let me draw, let's say, P over here. Let's say this is 6 meters and QR over here. So this is P, this is QR. are P is moving to the right with a speed of 4 meters per second. Okay, and I know that if this is 7, then this is going to be 1 meter, the distance between them, and they're going to collide somewhere in the middle. Yeah, so let's say that the distance they collide from, let's say that this distance is going to be x. So this makes this distance 1 minus x. Yeah. So now what I need to know is I need to know what is the speed of QR. QR is going to be moving to the left. Let's try to calculate what's the speed of QR. And we were on the right tracks to do it from here. So now we know that t was 0.8 seconds. We want to know what is v now. So to get v, I can use the equation that doesn't have a t. Or I can use any actually. But I prefer to use everything that is given better than something that I calculated because it minimizes the errors. So v squared equals u squared plus 2as. So v squared equals u, which is 2 squared, plus 2 times a, which is -5, times s, which is 0. So I know that v squared is going to equal, this part is 0, equals 4 square root. V is going to equal plus or minus 2 meters per second. So at displacement 0, okay, at the beginning I was moving up with a speed of 2 meters per second, hence the positive part of my answer. And then secondly, when I'm going down, I'm going to be moving down with a speed of 2 meters per second. That's why this is shown in the negative part of the answer. So my v moving down is going to be 2 meters per second, which is also going to be the speed that QR is moving to the left over here. This is a super tough question. You can stop and repeat the video, okay, to help you visualize what's happening. Now the final part, let's solve for x. We want to know what is x. Type for p, we know that velocity is going to equal distance over time. Now both of them are going to be moving with constant velocities because we know that at this section, the horizontal section, there is no external force acting, hence there is no acceleration, hence they are moving with constant velocities. So you just use v equals d over t. So for p, 4 is going to equal x over some time period that it took from p to move from here up to the collision. And for QR, again, we use v equals dt. So 2 equals d, which is 1 minus x over the same time period, because the same time is going to pass to both of them if we're starting from the same time frame. Okay, so now we just need to solve these two equations together. I can multiply a t up, so 4t equals x, and here I have 2t equals 1 minus x. I can straight away substitute x with 4t here, so 2t equals 1 minus 4t. Move the 4t to the other side, becomes 6t equals 1. T equals 1 over 6 seconds. So that's the time it took from this moment over here until the collision. Now to solve the final question, we just need to find x. So x is 4 times t, which is 4 times 1 over 6, which is going to equal basically 2 over 3 meters. So this x distance, the x distance is 2 over 3 meters. So the question wants the total distance from B to the collision. So it's going to be 6 plus 2 over 3, which is going to equal basically 6. So total distance is 6 plus 2 over 3, which is could be written as 6 and 2 over 3 meters. You can change it to fraction or decimal, putting 3 significant figures, but this is the final question. Honestly, this question is super tough, okay? But it was not only the first time it comes, it's just the first time it's this long. Sometimes you just need to cut your question into only 2 parts or something, which is usually easier. So solving this is going to make the other ones a piece of cake for you. Please, if you have any questions, leave them in the comments section down below. I'm going to look at all of them. Feel free to like and subscribe. It helps immensely, guys. You don't understand. Check my course in the description, and thank you so much for watching.